All right, 4.2 exponential functions. So we're going to be doing some just like general like properties of exponents and using them to graph some exponential functions, but I just do it using a table. There's other ways you can do it with like shifts and stuff like that, like we would have done with like parabolas and things like that, but I usually just do plotting points. It's the easiest, and with 3 points you can literally make an exponential graph. So we're just going to do it that way. But for these first few problems, what they've done is they have told us that f of x is equal to 3 to the x and g of x is equal to 1/4 raised to the x. And then it says to find each of the following round answers to the nearest thousandth if needed, which that should only really be a problem for the ones where they're asking you to plug in like a decimal number, which I'm probably not even going to do those ones. But 14... we have f of -3. So that just means that they want me to take the function f of x that they gave me, and wherever there's an x, I'm putting a -3. So this is going to be 3 raised to the -3. So the negative exponent, just as a refresher, means that I need to put it, well, it's my little catchphrase, put it where it ain't, make it positive. So we're going to move that whole piece to the bottom so we can make that exponent positive. And so this would give me 1/3 cubed. And what is 3 cubed? Yeah, 27. So this will be 1/27. So we are using rules of exponents for this, but it just looks a little different than how you typically would have done, or how the information would have been presented to you before, most likely. 16, g of 3. So I've got the g of x function, and I'll be raising it to the power of 3. Notice that the way it was presented, they've given you the 1/4 in parentheses. That's to make it clear that that exponent is going on the entire thing. So I've got 1/4 cubed. And exponent rules say, and I'm just going to, I know it's just a 1 on top, so it's not really going to change anything on this one, but when you have a fraction being raised to a power, that power goes on both the top and the bottom. So this would be 1 cubed over 4 cubed, technically. You would not have to write this step. This is just as a refresher on exponent rules for you. So on top, 1 cubed is just 1. What's 4 cubed? It's 4 times 4. 16 times 4.
60.
Yep, 64. So it would be 1/64. Now, if I ended up with something like number 20, f of -5/2. So that means now that my exponent is a fraction, also happens to be negative. So what I have here is 3 raised to the -5/2. So the negative sign says I need to move it to the bottom. So I'm going to have 1/3 raised to the 5/2. Does anybody remember what a fraction like exponent means.
Yes, it's the square root of 3 to the 5th power.
Yep, square root of 3 raised to the 5th power. So whatever the denominator is the root, and then the other one is your power. So this would be 1 over the square root of 3 to the 5th. And normally we don't want to leave radicals on the bottom, but for the sake of this exercise, it's fine. We just typically want to rationalize them, but. And technically, we could keep going with this and say because we have multiple 3s, we can pull them out in groups of 2 because there's 5 individual 3s here. So if we pull them out in groups of 2, we would have 1 over 3 times the square root of 3, which would give us 1 over 9 root 3. So the book may go this far, but as long as you can set it up, like I trust that you can like take it farther if needed. But I just want to be able to see that you can set it up and like interpret what you're supposed to do with that, basically. So just so you're aware there. Any questions on those ones? All right, the next thing says to graph the function, and we'll get to that when we get to that. So they give us something like what we just had, basically, like a number raised to a variable. And then they just want us to make a little table and graph it. So starting with 30, f of x equals 1/4 raised to the x. So that's actually exactly what we just had, I think. It was just g of x before. So what I like to do is make a table of like x and y values. And I like to pick numbers that are like super easy to plug in. Typically just using -1, 0, and 1 is like totally sufficient to graph these basic functions, to like give you like a good representation. Now, when we get to the ones that also say like +10 or something, we may want to shift the numbers that we're choosing, but even so, it's still not going to be anything super crazy. So I like -1, 0, and 1. Why do you think I like 0?
Because anything to the 0th power is 1.
Yeah. So that's just like super easy. Give me one right there. So that's just 1. What about something raised to the 1?
Itself.
Yeah, just itself. So literally no math involved for doing those two things. And then when we have the -1, it just takes it and it flips the fraction over, or if it was a whole number, then it makes it a fraction. So in this case, 1/4 raised to the -1 would just be 4. So super easy. I've got my table made, and then I just need to come over here and set up a graph, and you really only need the top chunk of the graph. Now, if the number was negative, it would flip it over, so you would then need the bottom. But simple little graph here, and then I just plot these points that I've just found. So -1 and 4 is up here. 0 is at 1. And at 1 it's at 1/4. And then we just, obviously these aren't making a line. We round them off. The thing here is that exponentials do not cross the x-axis, so they just kind of, I didn't do a good job of rounding it out, but anyways, it rounds out, and it's going to progressively, if I kept plugging in like 2, 3, 4, and I went out to like 100, it's going to be getting closer and closer to 0, but never actually hitting 0. And the only way it will go through the axis is if there's something that's causing a shift in my like problem, but we'll probably see one of those in a minute. I think that's part of this section. Maybe. Possibly. And just for reference, not that you need it, but this is a decay function because it starts high and goes low.
So we don't need it?
Yeah, it's not asking you for that. I just want you to be familiar with it. I don't know if it's something you could see on an SAT or whatever, but just so that you're aware that that would be technically an exponential decay function. See another one of these more basic ones. 34 f of x equals 1/6 raised to the negative x. So now when I go to plug in the numbers in the table, I'm still going to use negative 1, 0, and 1, but I've got to pay attention because this x has a negative on it already. Okay, so we said anything raised to the 0 power is just 1, so that one's pretty easy. Now, when I plug in negative 1, that's a negative times a negative, so that ends up just giving me a positive 1 up here, so that's 1/6 raised to the 1, so it's just 1/6. When I plug in the positive 1, it's a negative x, so that'll be negative 1, so that means I need to flip this, and so that'll be a 6. So this one's going the opposite way. So at negative 1, I'm at 1/6. At 0, I'm at 1. And at 1, I'm at 6. And then we just connect it again. It doesn't cross the y. So this one would be a growth function, which again, they're not asking you to say if it's growth or decay, but it's good to just be familiar with that. Overall. All right. These next ones say to graph the function, and it says to give the domain and range, which we'll talk about. I don't know that I'll necessarily put it on your quiz, but just so that we're familiar with it. 40 f of x equals 2 to the x minus 4. So I typically still use the same values as far as like negative 1, 0, and 1 when I do these. But just know that now you can't just look at, that one piece. You've got to also subtract off the 4 when you do it. So when I plug in negative 1, that means that's going to give me a 1/2. So I would have basically 2 to the negative 1 minus 4 would be 1/2 minus 4, which is 3.5, or you can just say 3.5. If you want to do it in fractions or decimals, I don't care.
Wouldn't it be negative?
Yes, thank you. I'll give you your cookie point in a second. When I plug in 0, I have 2 to the 0 minus 4, which is just 1 minus 4, or if I can get it right this time, negative 3. And then over here, when I plug in 1, I just have 2 to the 1 minus 4, which is negative 2. And then still just plotting points, although this one is going to be down in the bottom this time. So at negative 1, I'm at negative 3.5. At 0, I'm at negative 3. And at 1, I'm at negative 2. So this one's still a growth function. It's just been shifted. And so what you're going to find as far as the domain values, these functions take up all real numbers as far as domain goes. So the domain of this would be, you can either say negative infinity to infinity, or you can say it as all real numbers. Now the range that it takes on is whatever the lowest value is on the y to the highest value on the y. So on these previous problems we did, I said your graph cannot cross the y-axis. So your range on one like this would be 0 to infinity. But on this graph, it's been shifted down, and specifically it's been shifted down 4. So that means that the spot that it can't cross, which again you don't have to draw this on, but would be this -4 range. So any number that I choose from here on out, so if I chose -100, it's going to get closer and closer to -4, because if I put in -100, it's going to make this number closer and closer to 0. -4 would put you at -4. So the range of this would be from -4, not including because we can't touch it, to infinity. I don't think I normally put this on the quiz or the test as far as domain and range, but I do want you to be familiar with it. If you go on and take pre-cal next year, you would need to be able to know that. Yeah. Let's see, 56. F of x equals 1/3 raised to the -x minus 2. So still set the table. So with this one, when I plug in these things, I now have this stuff's all up in the exponent. So it's going to be a little different than this previous problem where I only had the number in the exponent and then it was being subtracted by another number. So this will give me 1/3 raised to the, well, negative and negative is positive. So basically that'll be 1 minus 2, or 1/3 to the -1, which would give me a +3. Putting in 0 would give me 1/3 to the 0 minus 2, so that would just be to the -2, which would be what? What does the negative exponent do? It flips it, so that would give me 3 to the 2, which is 9. And then when I plug in 1, I'll have 1/3 to the -1 minus 2, or 1/3 to the -3. That's going to flip, so it'll give me 3 to the 3rd, which is what? 27. So you'll notice huge difference here in this problem compared to the previous problem that we had, in that these numbers get really, really large, right? So a couple things. We can still work with that, and that's totally fine. I could use a different set of numbers here as far as the table goes, or I could use, I could maybe backtrack and go over and try -2, because when I put in a -2 here for x, what's going to end up happening? Yeah, which would then give me 2 minus 2, which is 0. So if I were to, I'm going to do it on this side over here, but just know that it would have gone over there. So if I plug in -2, then that gives me to the power of 0, which means it's 1. So essentially this graph has been shifted over a little bit. So as far as actually graphing it, you can either count by threes if you want to use 3, 9, and 27. If I want to use -2 for an x value instead, I can go over and then I don't have to go up as high. I only have to go up to 9 to get my 3 points on my graph. It's kind of just up to you how you want to do it. Doing this on the wrong side. Which is probably what I'm going to do. So this graph's been shifted over. So at -2, it's at 1. At -1, it's at 3. And then at 0, it's up at 9. And so this graph just gets big a lot faster, basically. But like I said, different ways you can do it. As long as you end up with 3 points on the graph, you're fine. If I went over and I plugged in -3, I would have had a much smaller number that's down there, somewhere between 0 and 1. So, what's the domain of this graph?
All real numbers.
All real numbers. What about the range?
0 to infinity.
Yep. And we're not including 0 because it can't cross it. Any questions about that? All right, 72. These ones say to solve the equation, so these are a little different. We're not graphing now. So they give us 125 raised to the x is equal to 5. So when I have something like this where there's like a number raised to a variable and it's like equal to something that I'm solving for, I like to see, is there a way that I can rewrite whatever this base is here in terms of 5? So is 5 raised to some power 125? What is 5 raised to what power?
3.
Yep. So this would be, I could rewrite this as 5 to the 3x. That's the exact same as what's written right there then, just written in a different way, is equal to 5. Now, rules of exponents say, or properties of exponents, whatever, say that if these things have the same base, their exponents have to be equal. So, that means that 3x is equal to, this has an I'm not going to say imaginary, but an invisible 1 there. So 3x is equal to 1, so x equals 1/3. And that would be solved then. If I plugged in 1/3 for x, then that equation would be equal. Okay, which would say take the cube root of 125, and that would be 5, so I can verify that that's correct. Let's see, 76. The heat just came on. 5 to the 2 plus 2x equals 25. So again, I want to see, can I rewrite 25 in terms of 5 to some power?
5 squared.
Yep, 5 squared. So 5 to the 2 plus 2x equals 5 squared. So then, same base, I can take their powers and set them equal to each other. So 2 plus 2x equals 2. So subtract 2. Got 2x equals 0. So x equals 0 is the way that those things would be equal. And sometimes you may be able to just see it, like you may have seen right off the bat, well, I know 5 squared is 25, so I just need this to be 0, and then it will be the same. If you just see it, go for it. But this is how you technically solve for it. Let's see, one that's a little bit more involved here. 86. X to the 3 halves equals 27. So this one's different in that obviously the exponent doesn't have the x in it. The x is the base. So I need to get x by itself. So the exponent right now is 3 halves, which is telling me to cube x and then take the square root of x. But I want to undo that. Okay, so to undo a square root, I need to square both sides. But squaring 27 is obviously a pretty big number. So typically I like to try to take the root first. So I would take the cube root of both sides first, which I don't normally show this step, but like just so that we can see what order everything's happening. So I take the cube root of both sides, so I'm left with x to the 1/2 over here equals the cube root of 27 is 3. Obviously, that's a much easier number to work with than whatever 27 squared is that I clearly don't know off the top of my head. So then square both sides to undo that. So x equals 3 squared is 9. So different ways you can go about solving problems like this, but you know, and you can do it all in one step. You don't have to like show all these little steps out that I just did. You can just get to your answer. All right, in your notes you had one formula for interest. So I'm going to review that really quick. It was A equals P times 1 plus R over N raised to the Tn. Well, actually, you had 2 because you had a compounded continuously also. But, anyways. So number 100, word problem here. Find the present value. I'm just going to say PV, present value. That will grow to $45,000 if the interest rate, or if the interest is, can't spell, 3.5% compounded monthly for 1 year. So I want to know when I will have $45,000. So that's the amount that I'm trying to get to. So that's going to be A. So anytime I have a word problem, I like to write out the things that I know and then okay, what am I solving for? So A is 45,000. The interest is 3.5%, but I need that as a decimal when I'm going to plug it in. So that's the rate that it's happening at. So the rate is R. So R is, as a decimal, 0.035 or 3.5%. Now it's compounded monthly, so how many times does that happen in 1 year? 12. So that means that n is equal to 12. And just for reference, some books use k for compound, like times compounded. So if you ever see k instead of n, it means the same thing, just a different variable that they're using. And it's happening for 1 year, so that means t is equal to 1. If something was compounded quarterly, how many times in a year does that happen? 4. I'm trying to think of if there's any other ones that they really... A lot of times it's compounded annually, which there's like a technically simplified formula for that, but that just would be 1, obviously. And a lot of times, like, they won't just have you doing it for a year. It'll be more than that, but in this case, that's all they're doing, so... Then ultimately, the only one thing that I have in my formula that I don't have a number for down here is p. So p is what I'm solving for. So in that formula, if I start plugging stuff in, I've got 45,000 equals p times 1 plus, have this right here, 0.035 over n is 12, raised to the t times n, so that's just 1 times 12. So on problems like this, there's really no way to do this other than by plugging these numbers in your calculator, because I don't expect you to be finding all of those things in your head. So essentially what I'm going to end up with is 45,000 divided by this whole thing in parentheses raised to the 12th. So I'm just going to write this over here, 1.035 over 12 raised to the 12. And then you would just have to plug it in to solve at this point. I think I've shown you all this before of how to like type in a fraction to your calculator, but just in case I haven't. If you hit alpha and then y equals, it brings up this option to type in a fraction n over d. And it just makes it easier since I have a fraction technically in here as well to be able to do this. So 45,000 on top. Down here, I'm going to put parentheses because I can just type this in exactly as it is. So 1 plus, I can either go and use that fraction option and input another fraction, or I can put parentheses and do the 0.035 divided by 12, close the parentheses, close the other parentheses, and then raise it to the 12th. But the easiest thing, in my opinion, is to do the other fraction. So alpha, y equals n over d to put in a fraction, so 0.035, and then 12. Close that parentheses, and then raise it to the 12th. And I know that's really tiny on the screen for you to see, but anyways, there's that. Hit equals. And so the initial amount, or the amount that I have basically right now, is P equals $43,454, and because this is money, we do 2 decimal places, so 46 cents. So that would be the principal amount that we started with, or the present value. I had a class laugh at me a couple years ago because I kept saying when we did these problems, they would like give me however many decimal places they were feeling at the time. So I kept saying money, money, money. And so then finally by the quiz they remembered what it was. But I was like, it's money. It has to be 2 decimal places. No more, no less. So if you ended with something, say it was like 43,454.5, you would put a 0 on there because we've got to have 2 decimal places with money. Any questions on any of that? Not too hard, I hope. There's not a ton of time left, so I'll probably give you about 15 minutes at the start tomorrow if you need it to finish this stuff up, maybe 20 minutes to make sure you have plenty of time, because I know these take a little longer sometimes to do. But problems 11, 21, 31, 45, 55, 73, 75, 99, and 101.